Hi there. Time to start learning about midpoints and bisectors, and you'll see that they're pretty closely related. Let's start with some vocab. Midpoint, like it sounds, is the middle point of a segment. So let's call it the dead center point. Now I'm going to give you a technical definition that's going to come in handy for you later on as we work through our course this year. So here, there's 4 different ways you can define a midpoint. Let's start out with the basic thing for all of them. Point M, we'll call it. Point M is the midpoint. And you'll see me use an abbreviation here. There's an abbreviation for midpoint. Point M is the midpoint of segment AB if and only if it is collinear, has to be on the segment, and I'm dotting that because you can use any of these 4 rules. Before we write out the rules, let's draw a picture of this. So let's take segment AB, and let's call point M the midpoint here. That looks like it's about in the center. Let me actually tick mark that so everybody sees that it is the center. Remember, tick marks mean that those segments are congruent. So I have 2 equal pieces. All right, so point M here is the midpoint of the segment if and only if it's collinear, and it is, and one of these 4 things is happening. Either, like my tick marks show, segment AM is congruent to segment MB, so the 2 pieces are marked as congruent. Second way you could look at that, it would be equals. The distance, remember distance from point A to point M. If that distance is equal to the distance from M to B, then M will be the midpoint. A third test would be to look at it as compared to the whole thing. Let's say that the distance from A all the way to B, that's the same thing as taking 2 of one of the pieces. So 2 times, we'll just use AM as an example. 2 times the distance from A to M. So the whole thing is equal to twice the size of one of the pieces. Then that means that that point M would be your midpoint. Now this also could be could be MB, of course. And then the last way you could do this is kind of a reversal of the number 3. What if you took only half of your AB segment? What is half of the AB segment? Well, that would be one of the AM segments. So that would equal the distance from A to M. Any of those 4 things is true if you know that you have a point that's a midpoint. So how do you find a midpoint? Well, there's a formula. It's called the midpoint formula. Pretty clever name. And what you're doing is you're basically thinking about center, so you want to just take an average. If you think about how to take an average, you just add 2 things together and divide by 2. So for midpoint formula, you want to find the average of the endpoint coordinates. And here's an abbreviation for endpoint. All right, let me show you how that works. Let's say you have a point and it's located at 10 on your number line, and let's call that point A. And you have another point out at 24, we'll call that point B. Where would the midpoint lie? According to our formula, we would just need to average point A and point B's coordinates. So to average them, I would take 10 plus 24 and then divide that total by 2. Okay, 10 and 24, that adds up to 34. 34 divided by 2 gives me 17. So that means that here at 17 on my number line should be the location of the midpoint. We'll call it point M. So again, this distance here, I'm going to tick mark it, would equal this distance here. All right, and then finally bisector. What is a bisector? When I think of bisector, I think of the prefix bi, which means 2, and sector means to cut. And so we're going to cut something into 2 parts. In this case, for bisector, that means specifically 2 equal parts, like a midpoint does. So as an example, you might have a segment, and there is something, it's typically going to be a line or a part of a line, either another segment or a ray. I'm going to draw it as a line that comes through that first segment, sound effects, and cuts right through it, but it does it so that it marks it into two equal or congruent parts. Like this. So naturally, this right here, this is the bisector. This segment has been cut into two equal pieces, and so you might guess what point that is. That would be the midpoint. So a bisector does always pass through the midpoint of a segment if it's a segment bisector. Okay, let's take a look at some examples. In our first example, we see this number line and several points labeled on it. They ask us first to find the midpoint of segment CG. So let's locate segment CG. Segment C is here at -2, and segment G is here at 7. So, like we saw in our definition for the midpoint formula, we're going to average those two values. We're going to take -2 and add 7, and then divide that by 2 to take their average. So what's the total of -2 and 7? That's a +5. +5 gets cut in half to average, and we find it to be 2.5 or 2.5. Let's see if that makes sense on our picture. So 2.5 would be about right here. And let's call this point, well, let's just call it point M. Point M is going to be at 2.5 on our graph. So let's name this point M. And we can show that C to M and M to G should be equal. I'll tick mark those. And it looks like they're 1, 2, 3, 4.5. 1, 2, 3, 4.5. The same distance from either side. Now as we look at the question for part B, we've got point F, and they name that the midpoint of segment AH. So in the last one we had to find the midpoint. This time they tell us where it is. And our job is to find the coordinate of point H. Notice that point H is one of our endpoints. So how do you, knowing where our midpoint is, how do you find one of the endpoints? Well, let's do ourselves a favor and let's kind of re-sketch the important parts of this picture above because it's getting a little crowded. So on my number line, point A is located at -4, and point F, another point for our problem, that one's located at at the coordinate of 6, and point H is somewhere so that F is the middle or the midpoint. So H is going to be over here to the right somewhere. I just know the number. So our job is to figure out what this value right here is. So one way I could do that is I could figure out, well, I could figure out the distance between the 2 points that I do know from A to F, and then I could apply that distance to go out to H. That's one way I could do it. Another way I could do it is to do the formula, which is I think a little bit trickier. So for your benefit, I'm going to do it the trickier way to show you how it works with the formula. All right, so the formula again is to average your endpoints, and that's the midpoint. So if I take an average of -4 and my unknown, I would add them together. I would say -4 plus something, and then average means I have to divide that by 2. So -4 plus something divided by 2 gives me an answer that's my midpoint, which was the 6 in this case. How do I find that something? Well, first thing I'm going to do is I'm going to undo that 2 by multiplying by 2 on both sides. And so that lets me do some canceling. The 2's cancel out. So all I have left here is my -4 plus something that had to equal 12. -4 plus what equals 12? Well, I'm going to have to move up here. -4 plus what equals 12 can be answered if I just add a 4 to both sides to cancel that -4. And then they cancel out, so my something is 16. 12 plus 4 is 16. So that would be my location for point H. H would be at 16. Let's see if that checks out. How far apart is -4 from 6? Remember our distance formula. If we do the distance from -4 to 6, we subtract those and take the absolute value. -4 minus 6 is -10. And so that distance is 10. And how far is 6 from 16? Same story. If I take 6 minus 16, I also get -10 in absolute value. And so that's 10. So they are indeed equivalent or congruent, and F would be the midpoint. So that's how you do it if you're looking for one of the endpoints when you know the midpoint. In our last example, we see this figure, and in our directions it says that the line AC here has bisected or bisects segment TV. So again, bisect is the verb for cuts right in half directly into two pieces that are congruent. Let me tick mark that to help us see it. This is a match to this. So we have to find the value or the length of TV. We're not going to be able to do that without figuring out some x values. So I'm going to use this relationship that these two pieces are equal, and I'm going to set them equal in an equation. I'm going to just say that the 7x plus 13 segment is the same thing or is equal to 15x minus 11 segment. And then my job is to find the value of that x. I notice that most of my x's are already here on the left side, so I'm going to keep them there. And let me take these 7x's and take them away from both sides so that they cancel off of this side. What do I have now? I've got 13, and on the other side I've got a total of 8 x's, and bring down that negative 11. Now let's bring the negative 11 off of this side. So let's add an 11 on both sides so that we can get them to cancel off from the left. The right. I don't know my sides very well, do I? So 8x is alone, and this adds up to a total of 24. Now I just need to reduce that down to 1x, so I'm going to divide by 8, make that say 1x, and 1x is equal to 24 divided by 8 is 3. Okay, don't stop there. They've asked us to find the measure of the length from T to V. That means we got to make a substitution. Let's go ahead and plug it in to our first expression where we see 7 times the x plus 13. And we got the value of x was 3. So let's put it in there. And 7 times 3 makes 21 plus 13. This segment is 34 units long. Now let's check. Let's make sure that this segment also is 34 units long, that we did our algebra right. So let's take this one, and 15 times the same x is 3 minus 11. 15 times 3 is 45, and take away 11 from that and we get 34, sure enough. So it's 34 here, it's 34 here. How long is it from T to V? Well, how many is twice 34? So TV would equal 2 times 34 for a total of 68 units. All right, that's midpoint. Hopefully you got it and you understand the difference between midpoint and bisector because they're pretty close to each other. You can use some of the same ideas.